So if we know the number of moles of solute in a solution and the liters in a solution, we can divide them and figure out the molarity of that solution. In this video, we're going to learn to do something a little bit different with molarity. We're going to learn how to use molarity as a conversion factor to go between liters in a solution and moles in a solution. So, how many grams of NaOH, sodium hydroxide, do you have to dissolve to make 725 milliliters of a 2.5 molar solution? Okay, what are we starting with? What are we looking for? We're looking for grams, okay? Grams isn't one of the things we can get with molarity, but we can get moles, and then we can go to grams from there. What we can plug into molarity is liters. That's the volume. Now, the volume here isn't given to us in liters, but it is given to us in milliliters. It's relatively easy to turn this into liters, then we can use molarity to get moles, and then finally, we'll convert from moles to grams. So those are the three steps that we'll use here. We'll start by taking 725 milliliters and turning that into liters. There are 1,000 milliliters in 1 liter, so we can use one of these conversion factors. Multiply it by this one. These cancel out. Left with liters. Since there are 1,000 milliliters in 1 liter, all I'm doing here is dividing this by 1,000 to get 0.725, not milliliters, liters. Okay, so there's my volume. Now I can take 0.725 liters and I can pull out the molarity, okay? 2.5 molar equals 2.5 moles, here we are unpacking it, divided by 1 liter. We could also flip this, but we don't need to, because writing molarity like this is all we need to do to cancel out the units of liters and leave us with moles here. Multiply through here, and we're left with, rounded to two significant figures, 1.8 moles. Okay, now we know how much NaOH in moles, but since the question asks for grams, we got to take this mole measurement and we got to multiply it by a conversion factor that involves the molar mass. So I've already done the math here. There is a sodium, an oxygen, and a hydrogen, so we got to add the weights of them all together here, and we can express that in 40 grams per mole, or 1 mole over 40 grams. I will use this version of the molar mass. I know that each mole of sodium hydroxide weighs 40 grams, so if I have 1.8 moles of those, I'll do that times 40 grams. 1.8 times 40 equals 72 grams, and that's how we get that final mass. Now, the molarity problems that you do aren't going to be identical to the ones that I'm doing here, obviously. But if you look at the steps that I use, converting between milliliters and liters, and converting from grams to moles, they're steps that you'll use all the time when you're solving for moles and liters using molarity as a conversion factor. And always, always, always remember that whenever you see a concentration given in molar, you can always expand that and unpack it to turn it into moles over liters, a conversion factor that you can then flip if you need to.